Advanced Algebra 2, Concept 17, Nth Roots and Rational Exponents. So if we were taking these notes together in class, I would have you do this exploration. So work with a partner, use a calculator to show that each statement is true. Of course you don't have a partner, but you can grab your calculator and check to make sure that this is true. So if you do the square root of 9, of course you'll get 3. And then on your calculator, take 9 and raise it to the 1/2 power. Notice that you'll get the same thing. Now, as we go through these, see if you can see the relationship between the expression on the left of the equal sign and the right of the equal sign. So put the square root of 2, or 2 to the 1/2 power, in your calculator. And let's round to hundredths place. So we'll get 1.41 for each of those expressions. So notice they are exactly the same. The third root of 8 is 2. That's the number that can be multiplied by itself 3 times. And then 8 to the 1/3 power. Guess what? That is also 2. The cube root of 3 to hundredths place is 1.44, and the same for 3 to the 1/3. The fourth root of 16 is 2. 16 to the 1/4 is 2. And the fourth root of 12 is 1.86, and 12 to the 1/4 power is also 1.86. So notice that each number that's underneath the radical is to the first power, and then each number is to a different root. So if we look at number 3, 8 to the first power, and then the third root of that. So in an exponent form, it's 8 to the 1/3. So the top number is the power, and the bottom number is the root. That's called a rational exponent, a fraction or rational exponent. So you could rewrite a root expression as a rational exponent expression. So let's rewrite each of these radical expressions in rational exponent form. So knowing what we just talked about, the power will be the numerator of the exponent, and then the root will be the denominator. So this is the square root of 5 raised to the 3rd power, or 5 raised to the, oh, I'm sorry, I've got that one wrong. Just a moment. There, 5 raised to the 3/2 power, because our power is 3, so that's our numerator of our exponent, and the root is square root, or the second root, and so that's our denominator. So B is 4 to the 2/4, or we can reduce that, 4 to the 1/2 power. 4 to the 1/2 power is the square root of 4, or 2. Now we can rewrite 9 to the 2/3 power. 2 is the power and 3 is the root, so it is numerator over denominator. Now we're just rewriting these. We're not putting them on our calculator and estimating. So the 5th root of 10 raised to the 4th power is the same thing as 10 raised to the 4/5 power. Now I wrote this as the 5th root of 10 to the 4th power just to show that the power can go either on the outside of the radical expression or inside. All right, E. So this is, I might have done this one wrong as well. I did. All right, so fixing letter E, that will be 15 to the 3/2 power. And then finally, the 3rd root of 27 to the 4th is the same thing as 27 to the 4/3. And then I went ahead and simplified that because I can evenly. Because the 3rd root of 27 is 3, and 3 to the 4th power is 81. Now let's look at this exploration 3. Oh, and I forgot to mention that, these are not in your notes packets, so these are ones that you would just do on extra paper. So this says use the properties of exponents and rational exponents to write the expression as a radical raised to an exponent. Then use the calculator to evaluate each expression. So I would like for you just to take each of these and put it on your calculator and then see what you get. So 8 raised to the 2/3 power is the same thing at the 3rd root of 8 squared, which is 2 squared, or 4. 6 to the 5/2 power, that's the square root of 6 raised to the 5th power, which is 88.18. 12 to the 3/4 power is the 4th root of 12 raised to the 3rd power, and again, we can put the power either on the outside or the inside of the radical. 10 to the 3/2 power is the square root of 10 raised to the 3rd power, or approximately 31.62. 16 to the 3/2 power is the square root of 16 raised to the 3rd power, or 64. And then finally, 20 raised to the 6/5 power is the same thing as the 5th root of 20 raised to the 6th power, or 36.41. So the question is, how can you use a rational exponent to represent a power involving a radical? So just as I wrote those, your bottom number in your rational exponent, or sorry, the top number, the numerator, is the power, and then the denominator is the root. So you can rewrite them as a root raised to a power. And remember, the power can either go inside or outside the radical. Now let's jump into the notes. So look at this core concept. So if you have a number or a variable raised to a rational power to the 1 over n, then that is what we can think of it as the nth root of a. So a raised to the m over n power is the same thing as a raised, or going all the way to the end of that expression, as the nth root of a raised to the m power. And then if you have a negative exponent, you're just going to rewrite that as the reciprocal, 1 over that expression raised to that positive exponent. Now, here's a little note on the real nth roots of a. So something just to know, maybe to commit to memory, you'll just probably learn these. So if your root is an even integer, so like the square root or the 4th root, and the number underneath, so we're thinking of this expression, is negative, then you will have no real roots. If it's 0, then you'll have 1 real root, which is 0. And then if it's positive, if a is greater than 0, then you'll have 2 real roots. Now, if n is an odd integer, so the nth root of, so that would be the 3rd root or the 5th root, then if a is negative, you will have 1 real root, and it will be a negative number. If you have 0, then the nth root will be 0, and if you have a positive number, then the odd root of a positive is just 1 real root, and it is a positive. This will make more sense as we do some of these. So we're going to find the indicated real nth root of a. So rewrite this as a radical. So n is our root, so the 3rd root of negative 216. So you're looking for a number that you can multiply by itself 3 times. That will give you 216, which is not 3. So we need that to be a 6. And then it's going to be negative, because we need to take a negative 6 raised to the 3rd power to give us negative 216. Now let's look at b. So the nth root of 81, the 4th root of 81. So what number can I multiply by itself 4 times to give me 81? 3. And in this case, we're going to give both the positive and the negative if we can. So we can multiply positive 3 and negative 3 by itself 4 times to give us positive 81. Let's do some more practice. So the 4th root of 16 is 2, and it can be positive or negative 2. So if you have an even root and our number is positive, you will have both a positive and a negative answer. Now the square root of negative 49, you know that that would be an imaginary number, so we just simply say there are no real roots for this. Number 3, the 3rd root of negative 125. Well, if we multiply negative 5 by itself 3 times, we will get negative 125, and that's our only answer there. And then finally, the 5th root of 254, we're going to estimate that on our calculator, and it will be positive 3 and approximately 3/100. Now you can evaluate some of these rational exponents and roots without a calculator. So let's try those. So let's evaluate the expression in a. 16 raised to the 3/2 power. So let's rewrite it as in radical form. So that would be the square root of 16 raised to the 3rd power. Now we're just going to give the positive root in this case. So the square root of 16 is 4. 4 raised to the 3rd power is 64. And you can put 16 raised to the 3/2 power on your calculator to check that. But it's just as easy to think of it as a root and a power and just simplify it yourself. So now let's rewrite b. So let's write that as 1 over 32 to the 3/5 power, which is the same thing as the 5th root of 32 raised to the 3rd power. The 5th root of 32 is 2. 2 to the 3rd power is 8. So our answer there is 1/8. Now, some you'll need to use a calculator to estimate. So first try to do it on your own, but if not, then use a calculator. So 9 to the 1/5 power. Well, if you think of it as a root, it's the 5th root of 9, and that's not even. So just put it on your calculator, and it's approximately 1 55/100. 12 to the 3/8. So that's the 8th root of 12, and then raised to the 3rd power. So that's approximately 2 54/100. And then finally, we have the 4th root of 7 raised to the 3rd power, which will be, you could put that in your calculator as 7 raised to the 3/4 power, and you'll get approximately 4 3/10. Now, evaluate these with or without a calculator. So try them without a calculator, and then if you cannot, if they don't have the even roots, then use a calculator. So 4 raised to the 5/2 is the same thing as the square root of 4 raised to the 5th power. Square root of 4 is 2. 2 to the 5th power is 32. Notice we're only going to give just whatever root they indicate. And since our problem is positive, we'll give the positive root. So 9 to the negative 1/2 power, that's the same as 1 over the square root of 9, or 1/3. 81 to the 3/4 power, that's the 4th root of 81 raised to the 3rd power. 4th root of 81 is 3. 3 to the 3rd power is 27. Now, 1 raised to the 7/8 power is the same thing as the 8th root of 1 raised to the 7th power, which is 1. And number 9 is just a repeat of number 5. So square root of 4 raised to the 5th power is 2 to the 5th, or 32. Anything raised to the negative power, you can rewrite it in reciprocal form. So 1 over 64 raised to the 2/3, or the 3rd root of 64 squared. 3rd root of 64 is 4. 4 squared is 16. Now 11 is already in radical form for you. So the 4th root of 16 is 2. 2 to the 5th power is 32. And then finally, the 3rd root of negative 30 raised to the 2nd power. Well, that is not even. You can do that on your calculator. You could put that in also as negative 30 raised to the 2/3 power, and that'll give you approximately 9 65/100. Now let's simplify radicals that have variable expressions as well. So we're looking for the square root of 36, x to the 8th. So we look for the square root of 36, which is 6. And then for our variable, we're looking for how many groups of 2x's are there in x to the 8th. So the square root of 36 is 6. And then there are 4 groups of 2x's in x to the 8th. So think of it as you're dividing. So you're taking the power of 8 and dividing it into groups of 2. And there are 4. So now we have the 3rd root of y to the 9th, z to the 10th. So we're looking for groups of 3y's. So there are 3 groups of 3y's. There are also 3 groups of 3z's with 1 z left. So that 1 z has to stay underneath our 3rd root expression. So our final answer is y cubed z cubed times the cube root of z. Now 15, we're looking for groups of 4 variables. So how many groups of 4 x's are there in x to the 8th? Well, there are 2, or x squared. There is not any group of 4 y's, so that stays underneath. And there are 3 groups of 4 z's and z to the 13th with 1 z left, and so that has to stay under our 4th root. When you have numbers and variables, you just take each term separately. So the 5th root of 32 is 2. There is 1 group of 5 a's and a to the 6th. There are no groups of 5 b's and b to the 3rd, so that stays underneath. And there are 2 groups of 5 c's and c to the 10th, so that comes out of our radical. And now finally, we're looking for 6th roots, or groups of 6 x's and y's. So there are 2 groups of 6 x's and there are 3 groups of 6 y's, and we have 3 x's left, so that's our power underneath for x, and then 5 y's left. All right, our last example, it's a real-life application. So a hospital purchases an ultrasound machine for $50,000. The hospital expects the useful life of the machine to be 10 years, at which time its value will have depreciated to $8,000. The hospital uses the declining balances method for depreciation. So the annual depreciation rate in decimal form is given by this formula, where N is the useful life of the item in years, S is the salvage value in dollars, and C is the original cost. What is the annual depreciation rate, or what rate did the hospital use? So we're going to plug in our values for S, the salvage value, which is $8,000, over C, which is the original cost, $50,000 raised to the 1 over 10, because it has a useful life of 10 years. Plug that into your calculator as you see it, and as a percent, it is 16.7% annually for its depreciation rate. All right, that concludes our notes on Concept 17, an introduction to nth roots and rationals.